talk about some leak interfaces and low leak technology here, and then we'll get into, I think, like the ELP stuff, and I'll let Bronson take back over after that one. Valves are some of the most numerous components that you're going to have in your facility. Probably more connectors, but they're not as regulated as the valves are. Valves are there to regulate your process fluid, from a control valve to a gate valve to ball valves and globe valves. We'll get into all of them. Most of them have a bonnet. Sometimes you'll see a welded bonnet. And we talked about those earlier with the monitoring pyramid and how it saves time, or takes less time to monitor it. Just have a welded bonnet. And the thing to watch for is little plugs on the bottom or injection points from a previous drill and tap and all that stuff. All those are new potential leak interfaces that they could potentially add to a valve, just making more monitoring for a technician. They're readily missed as well. Valve terms, you got a hand wheel, got a yoke, got a gland, bonnet, stem, body, a disc, and a seat. There's your packing details. There's your gland nut, gland stud, follower, and then your packing goes, well, I guess I got a laser thing there. Packing goes in there, so you can see all your leak interfaces, and we'll get into them more, but like Bronson was saying, you got 99 to 98% of them coming either from here or here. One of those two spots. There's gate valve. Got a low pressure drop when that thing's open. They're great. Probably the most common valve you'll see out there, and probably 3/4 inch size or something like that. And you're gonna see the most leaks from them. Check for leaks at the red arrow. So there's your stem coming out of there. There's your packing. Obviously that red arrow is going to nothing on there. We don't have a drill and tap thing on there, but if it was to be a drilled and tap valve, you have the potential for the threaded connection to go into that body of the valve where the packing is, and they inject that packing into the valve at that point. And now you are touching process basically with that threaded connection and the little ball valve that's on the end of that injection port. So we look for those. Oh, okay. So I'll just not use the pointer and stand over here. That thing's bright though. So this is your stem and your packing. Those two spots right there are going to be the spots that are going to leak the most. This is your bonnet down here. I don't know why, or somewhere. I don't know why it's not shown. Usually it's like right here. Yeah. Yeah. And then this here is the injection port that we don't have on the valve. But what they do is they drill into it, into the packing, and they put more packing into the valve to try and stop a leak. It's one of the extraordinary repair attempts that you can do under the leak, to stop the leak. So when they drill into it, they actually go into the packing all the way through the body of the valve there, screw in like a little ball valve, and then they have something where they inject more packing into it, and then they close the ball valve. So then right here, you'll have a threaded connection here where you screwed into it. We'll be touching the packing, and it's a new potential leak interface for you to monitor. A lot of times you'll see a technician glance over that, but since it's becoming more and more common these days to see things getting drilled and tapped, that you don't see it as much anymore. Like just in the 3 years I've done it, you notice a lot more people picking up on those and stuff. Sometimes it does. You don't expect it too much, but you got to realize they're only getting, on a smaller valve, you may only get 2 threads on that thing. So when they tap that and then put their injection port in there, they may only get 2 threads to actually get a bite on that thing. So, and there's a potential for it to leak there. I would say those leak more than a bonnet would leak. just because of the, I don't know, the threads that you're getting the actual bite on, you know. More packing. Yep, they use a hydraulic.
Including whatever you get into, I'm sure now it's filled with this packing material.
Yep. 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 And then on the end of that injection port, there's a little ball valve, just a little quarter turn. They turn that, and a lot of times you'll see a nut in the end of that. So there's several layers there, but mostly on the threads is where you'll see it leak at. Sometimes they don't put the nut in. People don't consider those open-ended lines, though, even though that's right up against the packing. They say the packing's their first line of defense, just like a stem and stuff. So if it's missing its plug, it's not a big deal, but I know a lot of places try and get those in there. So this is just showing you, what is this? Top of the wedge has a flat spot, mates with the bottom. This is just showing you how it's sealing on that, on the packing and stuff. So there's your seal right here. This is the follower coming down into the packing, compresses it right there. This is your packing spot, and then of course you have your bonnet again there. This little thing right here, I call that a follower. I think that's, do most people call it that? You guys call it that? It is connected to, it's connected to this piece that goes across here. So when you tighten up these bolts, it moves down in unison. So you're not moving one or the other. Well, I guess, you know, if you don't tighten them at the same pace, it'll move different, but the idea is to move them at one. How do you make it? There you go. Okay, sorry. Gate valves and low leak technology. Yes.
So what does this have to do with seating properly?
We're just showing where this stuff mates and stuff like that.
So that's where it moves.
Huh? Oh, backseating gate valves. Sorry. Just fully opening it. All right, it's a second line of defense, kind of. Gotcha. So advances in packing material make this stuff pretty effective. They got all the new packing out there. The API 622 test protocol says it won't leak over, what is it, 500 ppm in 5 years or something like that. I don't know the exact terminology on it. They'll give you a certificate and stuff, and they guarantee it for that. It's tested at temperature cycles and open and closed cycles as well. So that's something that's been to the market. They started adding those into gate valves, reducing leaks pretty drastically. The live load packing is another one where they can do this again online. So you're also getting much greater seals now after you do a drill and tap and loading it while it's still in process. You don't have to take the whole thing apart and repack the valve anymore. So all this stuff is bringing down leak rates and keeping these things from leaking as chronic leakers.
What's a live load packing? I didn't follow
The bushing. Where you take those off and add the packing while it's still in service?
Live load packing, what it is so where the follower is and the bolt
Oh yeah, I know what you're talking about. Gotcha. So they take these bolts off here. Is this what you're talking about then? They take, the hell did I get?
There's a diagram on page 106.
There we go. 106. Glad they, yep, okay. So yeah, they take these nuts off here, add a whole bunch of washers here, and then put those nuts back on. So that's what he was talking about just there.
So you keep that over time keeps a relatively constant pressure on the guide.
Yeah.
Do that at the same time as repacking and drill and tap as well?
No, this should take a little time to do that. So you put these on before you would ever get to that point. This is something to reduce emissions beforehand. If you have a leak, depending on your consent decree or what requirement, you're going to have to drill and tap in if you can't fix it based on the DOR in your CD. But by adding this in, like this is mainly started out on control valve, and what it did was because control valves are actuated all the time, and with this it helps keep the exact pressure that's needed on the packing to help load it into place so that you have less likely for the packing.
Go back then. Then you got the new bellow seal valves, and someone in there has some examples of those. Globe valves, throttle flow rather than just shut it on or off. Stem may be vertical, can also probably be horizontal. And frequent leakers until live load packing. So these usually are the ones you'll see the live load packing on. Check for leaks of the red arrows again. Again, you have the stem and the packing, and then you got potential injection points, got your bonnet, and then this one is the one that could potentially have that second bonnet there at the bottom.
So at the very top.
Yep, yep,
Red line.
yep. They're not trying to show it here. I think it should be here.
Okay.
It's just not in the right spot. It needs to be over here, where that stem's coming up through.
And is it fairly common, if I get my terminology correct here, that the bonnet versus the bottom part of the valve, it could just come up the sides where the bonnet is bolted on? Is that correct? Is that fairly common?
To leak on the bonnet?
Where the bonnet is bolted on to the main part of the valve.
No, that is not a common leak. Like you were saying earlier, most of your leaks are going to come in those first two arrows right here. This is your common spots, this one and this one. So those are where it's most likely to leak at. You won't see a lot of leaks coming from the bonnet, maybe 1 or 2%. Again, things that have helped this type of valve, you got your packing again, better manufacturers. Mini control valves already fall into this, and then your live loading packing that we've already talked about. And I guess there it is, the way Bronson explained it, some sort of spring or something to absorb that. Usually you'll see that in the form of a stack of washers. Ball valves, 90 degree rotation. These don't typically leak. I'm not even sure they have a low leak technology ball valve. I think they're just kind of designed not to leak. You know, they don't really have much in the terms of touching the process there that would leak out. The leak interfaces are as follows. There's just where the stem is most times. This might actually be One of them. Yeah, it is. So ball valves, usually when they put the ball in there, there's a threaded connection right there that goes all the way around it that allows you to take that ball out if you got to do any repairs to it or not. So that's another potential leak interface on ball valves. So that one's very commonly missed and overlooked when you're out there monitoring things. Kind of just looks like a seam on the valve where it would have been like molded together, but that thing actually comes apart. Yeah, ball valves are inherently low leaking. Most have not been certified as a low leak component.
How is that usually identified in consent decrees? If they're inherently low leaking, is there still a requirement for putting in low leak ball valves in consent decrees that you've seen?
You would just say that it's not available if they needed it, because I don't know of one that's actually certified as low E. Do you?
Not that I know of.
So like if you had one that leaked and you had to replace it per like a new consent decree or something, you just say it's a commercially unavailable product.
You have to be sure that you reach out to the different vendors to basically show that it is unavailable. And then with the low E and with all, there's tracking requirements with it. So you're gonna have to make sure that you have all the certifications for any of the low E. And you have to have a written guarantee that says they will not emit above 100 ppm for 5 years.
And you don't.
A good one to reach out for you.
Yeah, they have that, don't they?
Yeah, I just didn't know how it addressed ball valves. I don't recall reading.
It says for valves, it says it's valves and packing. So that's what the low E sections are. It doesn't call out specific for a twin seal usually use this.
Right, so you just have to demonstrate that these aren't available.
Yep.
And it changes all the time.
And check once a year to make sure they're still not available.
Plug valves, similar to a ball valve, they got the 90-degree open and close. Looser tolerance with sealing and lubrication. You can use a grease gun to seal these things. Now have inserts, high precision construction, multiple sealing levels. Again, we're going to get back into the leak interfaces here. They're going to be same as a ball, same as every other valve. You're going to have a stem that comes through, and then your packing. And then for these, we added this one here. You got some grease injection points in those things, the Zerks. So make sure you check those too. All that stuff kind of leads into it. And a lot of times when these things leak and you pack more grease into them, same way with like a orbit valve or something, when you just start packing grease into these things, you'll see them just repetitively leak over and over and over. So, as I said earlier, grease will sooner or later be saturated with the VOC and leak out. It's not a good sealing method, but it works for a while. Lubricated plug valves without an adjustable packing will not likely meet the low leak technology standards. So plug valves with an adjustable stuffing box may meet the standards as designed or with an addition of an advanced packing material. And manufacturers are offering the low leak plug valves though. And there's some of those manufacturers. Butterfly valves, mostly used in gas service, probably always used in gas service. Provide throttling and blocking functions. Again, a 90-degree rotation on them. Seals like any other valve on the stem. The bonnet can be hard to tell from mounting flanges. So again, you have your stem. You got a semi-bonnet here. But usually these are considered part of the valve in this one instead of actual flanges. I know when you're looking at a valve, you think that the flanges on either side of it are just connectors, but in this case, you treat that as part of the valve most times. And then again, these could have a second bonnet on the bottom of them. Another thing to watch for. Low E butterfly valves. Most butterfly valves with enhanced leak technology are focused on minimizing leaks past the disc, not to the atmosphere past the stem. So again, you'll probably go with something that would be unavailable if you can't find something. Again, it's going to be like your ball valve. Orbit valves, these I talked about. These, again, these things tend to leak a lot too. You can, they have a frictionless opening. They have a unique ball inside of them that kind of doesn't really so much turn, but it's got the tilt and turn thing to it. And again, check for leaks here. You got a bonnet. Sometimes you'll have a bonnet at the bottom. You have usually this bolt here that goes through it. You have grease circs on it. You have a second stem that goes all the way to the top. That's why the arrows are at the top there. So it just has a lot more leak interfaces to worry about. They leak fairly often. Usually you'll see, like, I guess that one's kind of it, but you'll see those things have cut out in the side of that body there that you can stick your probe down into. Rising stem ball valves, which I don't know why they don't call them one and the same. I think an orbit valve and a rising stem ball valve are kind of one and the same. Orbit's just a manufacturing company.
I'm curious, you going over all these potential leak points.
Uh-huh.
How does the reg itself address all of these? Does it call it out specifically, or this just becomes a work practice?
Right. You'll go over all leaking interfaces.
Potential leaking interface.
Yeah.
Yep, so out of all of these red off arrows, those are potential places that you will find.
Yeah.
And when we go out and do audits, and some of these type of valves, you'll see newer technicians go out there and monitor more and or sometimes less, but usually not less. I mean, they're going to go out there and monitor way more than they need to. I mean, I've seen people, when you're doing an audit, go out and monitor the handle of a gate valve. You know, just no idea why. Probably just nervous of someone watching them do their monitoring. But, you know, there's a good amount of turnover in a plant or something. You get some new people out there and you have an auditor come in within 3 months of being there. They're going to try and do everything they can to not be watched. So better to monitor more than less, but it's quite the waste of time when you're doing something like that.
So with so many leaking air potentials there, what would be the expected time of sniffing it? Like 10 seconds, 30 seconds, or 3 seconds per area? How do you?
Just, you know, you try and move your probe at the same thing. A lot of people won't differentiate between one or the other, the type of valve or anything like that. They just do it based off the size. So say it gets like a 30-second scan time put in it. If it takes you longer, there's no issue or anything, just as long as you hit all of them. So, you know, it could take you 30 seconds to up to a minute, but you know you're just going to move around the thing as your instrument's going to respond to it, and you're going to dwell and all that stuff. So just however long it actually takes you to do it all. I wouldn't say there's a set time or anything to do it, but just as long as you monitor all the interfaces. Because I mean, this little bolt right here that's sticking out, you know, I mean, it might only be a 1/4 inch or something like that. You know, it's going to be fairly quick to move around it. And then this part up here, same thing, that little stem that comes out the top, it's fairly small. doesn't take a long time to monitor that either. So it's all dependent on the technician and the instrument and the response times and how fast they're moving. But there'll be a minimum put in on it too, just because they usually just dump that into guideware. It'll be like, or leak DOS, whichever system you're using. I don't know if there's many others out there, leaders, a couple others, but usually they just populate those based on valve size and put a minimum scan time on them. So these, you don't ever see them get anything special. Do you see them in there different? Like have different scan times per component type? It's all based off size? Yeah. We'll have a subclass that'll say that. Or compressor or whatever else is out there. So like I said, I think these are the same as an orbit valve. Just think that Orbit's the name of a company that makes them and it's kind of stuck on. So let's see, these valves have a few rings of internal packing, just like a gate valve would. Primary repair technique is by injecting a fluid packing. I'll see, there we go. Rumors that Orbit has a low leak version is under development and testing. So again, you're not going to be able to find a low leak one yet. I don't know why we changed the name from Orbit to Rising Stem and then called it Orbit again, but we did. Twin seal valve. So that's just a trade name. These are single actuator for a double block, optional bleed system on them. Sometimes you'll see that bleed, usually you see that bleed wrap back to process. Sometimes you'll see it bleed to atmosphere. The ones that wrap to process are probably a little nicer for that, but sometimes, so these are all the leak interfaces on it. And it says check for the open-ended lines. This is where your bleed would go to atmosphere, right down here. Sometimes you'll see the bleed come out and be routed back into the process on those too. As far as tagging and stuff on these go and identification of the component, you'll see all these and there's this valve here. Some people call that its own valve as well. You see it both ways. You see people saying that's part of that twin seal valve as a whole, or you see them call it out as a completely separate valve. Either way is fine. As long as you monitor all the leak interfaces again, that's all you're required to do. So whether it's one valve or two valves, it's monitor everything.
So is that one OEL?
But that goes back into the same thing. That goes back into the same thing I was talking to you about on the drill and taps. I don't consider them open. Do you?
Yeah, it is.
Do you consider them open?
And the reason why, and I mean, it depends on how your site handles it, but the reason why we only have one valve seat controlling that atmosphere. So unless it's routed back, you can prove that it's been purged, then you could potentially say that. But it depends on who you have. Some folks will just walk straight down the line. One time I think we had like 75 open to the road.
But I thought most people considered the packing in that thing as their first line of defense on it.
And so, like I said, it all depends on what stance you want to take. And who's actually
There you go. So I guess some plants don't call them open ends, some do. You know, have some documentation in place in case someone asks. That would be my only recommendation about it.
great for leak detection and repair, but it's all about documentation. Whenever you decide, just make sure it's written somewhere that shows that this is the decision you made. Because at the end of the day, that's all it really matters. You can support your decision, but have it written down to show why you made that decision.
You still see a lot of them with that vent to atmosphere, or do you see it going back to the process these days? Yeah. Because Alco makes a double valve, handled type valve with, I guess there's 2 valves in there. So there are many different styles, single valve, body, multi-handle. Less joints means less probable leaks. No guarantee or anything. So those are not low leak technology either. Are they? Then you're going to have the same leaking interfaces as you would like with a ball valve on those, though. So I don't know if we have the next slide shows you those, but I was just letting you know. Straumann valves or sample valves. These, they have like a little plunger in there, comes down to here probably, and you crank that, it moves past, liquid comes out that part of it. You usually see those on like the side of a tank or something. Usually there's a second valve in there. Those they do consider open-ended lines on those. All the spots you would check for leak interfaces, the top of it, a little probably like injection port or something here, and then your bonnet. And it says check for leaks at the, or check for an OEL at the green arrow, but like I said, most times you'll have a second valve there. It's just easier than a guy going out there and taking a plug in and out every time he wants to take a sample. You can just put a simple quarter turn ball valve there. Straumann valves, hand operated piston like I was saying that goes down past that and causes a seat. You have a small stuffing box. No tester guarantees on those either. So for the most part it's going to be on your gate valves and stuff that we talked about earlier. Sight glass valves, I don't know what most people call these. See them in the database as like a Koch valve or a Jurgensen valve sometimes. But there you go, often called a Jurgensen. I got a union, a bonnet, nut. I got the stem that comes through, and then a whole bunch of places that like all these things tie together. So this is like a threaded fitting on here where you have a potential leak interface there. You got another one on the back side. Usually you'll see another bleed valve coming off of here as well to bleed those. Then you got this one. Some plants actually treat those top ones in that back side where it ties in as connections. I don't know, do you guys treat that as part of the valve or do you treat it as connections as well? Is it? Yeah. So those are usually treated as connectors. So the only real spot you monitor is where the stem comes out of here and then this right here where the, I guess where your packing would be in there. There's only one valve. There's only one valve here. This one really is the only one, but you have these connections here. I don't know if it's other unions and mounting connectors. Most plants will not treat that as part of the valve, like he was saying. And then usually they add so these potential open-ended lines where these green arrows are, usually there's a second bleed valve on there. So you have your low point bleed here and probably a higher one there. And I probably have seen it without the valve once or twice. I mean, it's fairly rare. Usually you'll see the other valve there. Low leak technology. Again, you can backseat these when fully open. Small stuffing box. I don't think there's any guarantee on these, but I'm not 100% sure. I would think there wasn't, but people aren't testing those, I don't think. Check valves, monitor around the bonnet there. Sometimes you'll have an external actuation here where the pin is. Most people don't treat these as valves. Usually go in as a connector, and they're either never monitored or if they don't have that external actuator thing there, they'll just treat them as a non-detectable and usually never monitor them at all. You guys treat them as connectors as well?
Yeah, for the most part, they actually, some facilities are trying to stay away from them. They just call it flopper, if they use the word flopper, it's not gonna be able to monitor it.
So they don't even call them check valves then? Gotcha. Do you guys put them in as NDE as well then? Yeah. So, yeah, most times you'll never monitor one of those things, but they get treated, like I said, they get treated as connectors. He calls them floppers, I guess, which is a rather weird name for check valve. I guess that's all it is, right?
Like the only potential leak interface
If it's here, and this, but yeah, so nothing really. But a lot of times you don't see that bolted, you don't see that stem anymore. All those are internal these days. So they've gone away from that as well. All check valves could be considered low leak. There's no stem seal. As I was saying, they go in as a connector, so you won't ever really monitor them. They only have this bonnet flange, and that's the only potential leak interface. They're usually identified as a check valve, and then they give it a subclass as other, or they give it a class as other and a subclass as check valve. I don't know which way they do it. Do you? Gotcha. I've seen it where they do classes, other, subtype as check valve, and they just don't have those as under any requirements or anything like that. So, however it goes in your system, just so you know the difference. They're all designed to operate at less than 100 ppm, pretty much for the most part. I mean, I guess all valves theoretically are, but obviously they don't operate like that. Pumps and compressors are your two primary movers of the plant. You got a drive shaft that either rotates or reciprocates. Your shaft seal is the main leak point, but other body seams can leak. I'll get into some of these. This is a pump, all your leaking interfaces. And you got your shaft seals and stuff. Probably a little mounting flange right there or something. And then you want to get all the little nuts and stuff that are going into that. So as long as it's part of the pump body, they consider it part of the pump. I don't think I've ever seen anywhere where they treat those as separate connectors or anything. They just monitor it all, any leaking interface on the pump as part of that pump. So those take a little while, or a little bit longer to monitor than your typical valve will. But again, you don't have a whole lot of leaking interfacing parts there, except the seal, a couple of bolts that usually stick through it, and a flange. It's a vertical orientation of one. Again, you just kind of have the same thing with the, you'll have a rotating shaft through there. You got some flanges and some bolts sticking through. Do you guys do the mounting flanges on those as part of the, you don't? Okay. I've seen that done both ways. You know, just however you do it, just try and be consistent with it. Sealless pumps, these are, you can get a can pump or the magnetically driven pumps, which I talked about earlier. They just got the little rotating shaft that spins. Compressors, if you ever have to monitor one of these, I kind of feel bad for you. They can take an hour sometimes. Depending on how large it is. There's just tons of interfaces throughout these things that have the potential to leak. Anywhere that, you know, piping's going in or out, all that stuff, just consider that goes into the body of that is considered part of that compressor. They're also kind of a nightmare to determine what's in service and what's not in service when you're out there looking at them. Barrier fluid reservoirs. Someone brought these up earlier, but they're pressurized or vented to a control device. Kind of see a pretty good mixture of both of those. And some of them, 50% have like a nitrogen blanket on them. The other 50% you see out in the field are going to go straight to your CVS system. You see a valve usually right here, and then there's a check valve after that. That's where most people call their CVS system, starting at that check valve. Some people tag the top of those. I know I just left a place that had an argument that they don't tag the top of them. I would think if it's a light liquid pump, you'd have the potential for something to flow back through there. I don't think you'd ever get to 300 hours of in-service though. I mean, with your pressure gauges and stuff like that, I wouldn't think you'd ever trigger an LDAR applicable valve up there, but to be safe, you could tag it. The barrier fluid's gonna be a heavy liquid. As I said, most times like a royal purple or some kind of oil in there. You have the sight glass. This is generally components on the top should be tagged. Like I said, some places will make a case that they don't have to tag the top of those. I don't know how you guys do it or anything, but I've seen it both ways. Low leak pumps, dual mechanical seals with the barrier fluid. Basically the new standard out there. The EPA allows the exemption from monitoring monthly as long as you have your audible alarms and stuff. So you got to have sensors and alarms, and you got to continue with the visual inspections though. And those are, like I say, they require them weekly. Operators are obviously doing a round every day, probably every shift. So you're getting 2 rounds a day, if not 3 sometimes if you're on 8s. So they're writing all that stuff down and reporting it, and you'll fulfill those requirements fairly easily. Cannon magnetic driven pumps have been rare. They're starting to make a scene into the industry these days. There's a couple of manufacturers there who are making them and what they're moving around. So say early compressor seals use a labyrinth to create pressure drop that would limit leakage. There's some advantages to seal designs like those. Let's see here. There are liquid ring seals now which work well in vacuum pumps and other low pressure compressors like those used in vapor recovery systems. Many compressors can be fitted with dual seals with nitrogen as the barrier. You're starting to see that fairly common. And so your enclosure of the distance piece with the vent to the flare is another form of control. Pressure relief devices, these things have a spring in them. I think we'll get to that. They're exempt from OEL requirements if they vent to the atmosphere. You got to monitor it if they vent to the atmosphere. You got your rupture disc on there too. See some facilities go to that. You got a primary leak point, the discharge, which would be up here. There's a vent hole in the bonnet, may also leak. You can see that they put that on there. And then you have an actual bonnet itself. These things are usually, I thought someone said something. These things are usually not monitored if they go to a closed vent device or something like that. They typically discharge to a flare header or via horn to the atmosphere. So you want to monitor at the center of the horn. So here, instead of springs, pilot operated PRVs have a since lining routed to a pilot control system. So you got this thing here. So it looks like they're just putting pressure on both sides, equal pressure on both sides of it. Supplies pressure to the dome to close the valve after the pressure below. So just another type of PRV. The rupture disc, these things pretty much guarantee you'll have a seat on your valve, and you shouldn't get anything to leak past your rupture disc unless it's no longer there, ruptured. And then you have your PRV after that. So you'll see them in conjunction with each other. Yes? Yeah, the orifice plate's like a flow thing, right? So this one just actually stops it all together, right? It has a breaking point. So the most common low leak control is to vent the PRV to the flare header, or mounting a rupture disc under the PRV is considered 100% control. Like I was saying, you'll usually see those in conjunction with each other. It'd be a rupture disc followed by the PRV right after it. There are bonnets and pilot control vents that should not leak, but they sometimes do. These are on PRDs. They're not controlled by venting anything to the flare. Those things vent to the atmosphere if they're going to leak. So none of that's actually captured like if it was going to the flare. What's this? Connectors. Variety equipment designed to join pipes. And we all know what a connector is. Flange, unions, threaded fittings, compression fittings. Leak interfaces are generally obvious. Right there, just typical flange. Got a leak interface there. Some kind of gasket in there causing those two surfaces to seal. I don't ever monitor the bolts. You don't monitor bolts, do you? Just around the actual seam?
Yeah. Everything.
Gotcha. Yeah, I never have, just around the actual seam there on that. Unions, you all know what those are. They got a, there's your leak interfaces where they screw together. One here and on the back side. That was actually a pretty good picture of it. Threaded connections, where the male end joins the female end. Compression fittings, swage lock stuff. Again, you got your two interfaces here again. I was surprised to found out the other day that those things can hold a fair amount of pressure behind them. I was real surprised when they were telling me about that. It's like 600 pounds or something. Low leak connectors. Welds are the ultimate low leak. It's possible for a weld to leak. We've seen them. It happens. You'll see it. I mean, you're not obviously out there monitoring welds to see if they're leaking or anything, but you'll see if a weld's leaking or something, you'll have some kind of elevated background somewhere, and then you just track it down. With the cameras out there these days, it's making it a lot easier to find these type of things. And then back welding valve bonnets can cut monitoring time. Starting to see more of those too, huh? That was probably me hitting my arm. Keep thinking someone says something. Lock ring may be another interesting low leak alternative. I don't know what that actually is. I haven't really looked into it. Do you know what the lock ring stuff is? Do you know what this stuff is? Some type of connector. So I don't know what that actually looks like in the field. Do any of you guys know? You do? Interesting.
It's a more mechanical method of compression.
Interesting.
Yeah, so like if, you get your reliability pressure valve, it might be a way to put a pipe in without doing a well.
Okay.
This equipment's actually on pipe, not just.
Okay. Probably like that new stuff you can buy for your plumbing and stuff. Gotcha. So I know what that stuff is then. I know what you're talking about. Did not know that's what it was called though, so. Gotcha. So then you got a little summary here. Just need to know about all the components out there. They said some of them are tougher than others, with the potential leak interfaces being underneath the valve sometimes. You know, see that a lot on your butterfly valves and other type of valves. Low leaking component or low leaking technology is set to change. The emphasis of LDAR, so it's bringing leaks down. We're seeing that fairly drastically at a few plants right now. They're installing only low leak technology, and their leak rates have steadily come down, and they have graphs and stuff that show that. So you actually see strides being made. Probably makes a technician's job super boring to go out there and monitor nothing that leaks. I wouldn't imagine doing that for 8 hours a day though. And then we'll go into some ELP stuff. You want it, Bronson? Huh? Do they get a break now or no? I don't know when your next break is. I don't want to run you guys past it. It's 40 minutes. ELP stuff. You probably know a little bit about this from BP or something. ELP backgrounds, negotiations, implementation, termination, and then a conclusion. So a few parts to talk about on here. With everything? People are yelling they want it done, man. That's right. Are they bringing it into here? Do you know? They're not? I don't know. That must be something else I was thinking of. They said I had 2 pages. Oh, okay. Gotcha. Okay, no worries. CDs, 90% of the refineries have CDs. If you don't have a CD, you're pretty lucky. Chemical industry doesn't have them. Yeah, well, they're starting to get them. They're not there yet. They're going to do a second round of CDs. Some of you have seen that. Well, maybe some of you have seen that. I know a few plants have gotten a second CD. EPA has expressed little confidence in the effectiveness of traditional LDAR. And preventative maintenance, equipment upgrades using certified low leaking technology is one of their big pushes. That's where this ELP comes in. You got some implementation stuff here, spot checking in large and small refineries, greater scrutiny on sister sites. That's only if you don't have a blanketed CD. Most CDs, I guess, were probably blanketed. At least majority of them, I think, were, that covered all the refineries within that company. So now that they're breaking them up, each site's getting different ones, and the first site to get it's getting off easier than the next site. CD termination, like he was saying, we have not seen it happen unless you close your facility down. You can try and demonstrate all the compliance you want, show all this stuff, but no one's got out of it yet, and first rounds of CDs are getting more stringent. So as the final places get them, and these new chemical industries are getting their first round of CDs, they're getting more and more stringent with the low E technology. Leak definitions are coming down Repair timeframes may even be getting tighter. There's larger penalties, I guess, for some of this stuff. But in the end, they're making these things tougher and tougher to abide by if they weren't tough enough already. Chemical plants, second round of refinery CDs. Some requirements in the first round of CDs. These are in the enhanced program. So LDAR personnel definition has expanded. You're not just with your monitoring tech, your site coordinator, your plant manager, a few technicians out there. There's a lower leak definition, 250 to 2,000. Of course, these guys out here in California are probably laughing at us saying they have lower leak definitions just within their counties. So they're already under it. They're not too worried about it. They're bringing in more component types, and they're doing a 12-month remonitoring for any leak under a skip period. And then you're going to have to make extraordinary repair attempts above 250. I think I've seen some of these or read lately that someone was having to replace any valve that leaked or something. Was that ever implemented, Bronson? Do you know? It wasn't? Gotcha. Someone probably had better negotiation skills than someone else then. Equipment replacement. So repack or replace every valve that leaks above 250. Well, apparently it's in the slide, so maybe it did happen. Repack or replace the valves with readings between 100 and 150, up to 10% of the total valves. That's 10% of the total valves, I think, that leak at that definition. We're not talking total valve population in the whole refinery, I don't think, there. Connectors that leak at 250 or above 2 out of any 3 consecutive monitoring events must be replaced. Your enhanced LDAR program, there's more to it. You got an enhanced QA/QC. I know one consent decree that came out that was enhanced. They had to do quarterly MOC walkdowns. So that was another thing that was added onto their annual audits instead of every 4 years. Well, they're every 2 years, but you can have an internal one and then external as long as you alternate them. Most people don't do that. I guess plants like to bicker about it and nitpick at each other or something. And then heightened stipulated penalties. Your open-ended lines are going to start costing you more. Mismonitoring will cost you more. All that good stuff. So they're making it tougher. DOR limits, extraordinary repair redefined. Maybe they'll add something in there about 409 or something and make people actually do some repair attempts on it. I don't know. Let's see here, stipulated penalties, getting stronger like we said, and then you got your valve repair program as well. Negotiation begins with a standard set of proposed terms. So these, forget the one that was going on, but it was in negotiations for quite a while before the enhanced program ever got out there. Just like I said, they're very stringent. If you try and get something worded the way you want it to be worded, then they add something else. So it's a hard bargaining place to go, I guess. Like you're not going to get something taken away unless you get something else added, basically. Let's see what else is on here. So you're limiting the applicability possibility. Most petroleum CDs applied to all refineries and all refinery process units within an oil company. I already mentioned that. New chemical CDs are being negotiated and published. They'll limit the ELP to only one facility within that whole complex of facilities. So again, that goes on to the sister company getting the worst end of the deal. Whoever gets the first one gets it easier. EPA sees what they missed, and then they add it into the next one. It just keeps getting tougher and tougher to comply with these things as they go down the road. Most facility CD negotiations include a trade-off between the action level for initial repair and the availability of skip periods. Again, we talked about skip periods and how they're not the greatest idea. State rules usually don't even allow them. So, these are action level at 200 is kind of common. Or 100 is this guy's attempt anyway. So you're getting lower on these things. It's going to happen. Try and get the most you can out of them. With low E, EPA is becoming more tolerant of skip periods, so you might try, bring them down to an action level of 250, or a leak definition is down to 250. On performance-based monitoring frequency, that's the one that'll actually allow you to go yearly if you have a low enough leak rate. And with the low E technology, you can get down to those leak rates. It's just, again, with the skip period stuff, it's scary to get into because it's hard to get out of. Unless you just go back and remonitor everything monthly, twice, and then just go to quarterly and call it good. Recent draft language from the EPA requires electronic data logging for all monitoring events. This one, I'm not a big fan of that. There's people that go out there, do a paper log for some sort of remonitoring event. We're out at a facility the other day, and I actually helped some guys monitor. I did it on paper logs, and I just typed it back in. And when it's needed to be done, it can be done. I would think a lot of these places say, just make sure it gets into an electronic database after, within a certain time frame, so that you don't have the paper logs anymore.
So the recent draft language, so you've seen somebody's draft CD?
I have not myself. I know he has.
Because I'm not chatting with EPA about hours ago.
They haven't sent you a draft or anything yet?
Oh, yeah, and it's not in there.
Okay. Do you? I know California requires everything to be electronic. That's in just their state rules, right? That's what I thought. And I know that was an issue with California for a while because they have the tiered monitoring stuff. So they have a 100 within California, but it didn't trigger the CD, which was at 200 at some sites, and then the actual leak. So they were having anything above 100 to 200, which was their action level for the CD. They weren't recording those in the data logger so that it didn't think that it was an actual regulatory leak type thing. But I think it's since been fixed since I was at the facility I was at that was having that problem. But they would do all those on paper and then transpose them back into the database, which makes for, right here, a whole bunch of a mess. But then try to negotiate some exemptions. There you go, Dow Midland. CD has an exemption from components not in the data logger route. So if you have, a random component that was added during midnight before you go out there and monitor it, surprisingly enough, it still does happen. Tag it, monitor it, come back, put it all in the database right then and there. There's no reason that you shouldn't be allowed to do that. So, let's see here. Use of low E technology is one point that the EPA is adamant on putting into any future CD. And we can ask him right now. Have you seen that top bullet point in any of the draft stuff? Yeah, have you seen that it says anything about it?
Everything has to have a standard on the newer. Some of the older ones allow paper usage for smaller routes or rechecks. You still have to write down the times and everything to put that in there. And they're moving to completely make sure that everything is electronic. And it's only in some of the draft language.
Back here. There you go. Murphy CD has a exemption for small valves to find a sampling or instrumentation valves of 5/8 inch or less. So they even got it larger than, I guess, the Hahn one. So 4/8 is a half, so 5/8 is a little larger than that. I don't know how they pulled that off, but good for them. If you take the exemption, most people don't even take the exemption. You know, there's 3 little valves on an instrument panel. Just go monitor them. It's not very hard. So what else we got on this thing? Chemical plants could try to limit the upgrade to the valves and not to connectors where there are fewer low E options. New draft language is requiring that valve packing be torqued to specifications before going into service. I've heard stuff about that. You put it under pressure and heat and all that stuff, and then you got to go out and verify all the torques on the stuff. So it's a lot of extra work to go in there. A hot torque back to specification after coming online. Try to negotiate some exemptions into that. And then see here, although it should not happen, the proper materials control is possible to cause more leakage by hot torquing a component. So probably don't see that a whole lot. EPA will start most CD negotiations what they call to do call to do away with DOR. So I mean, it's going to be coming, I think. If you think about it, California right now is somehow managing to survive out there without DORs, and you guys aren't allowed to have open-ended lines and all that good stuff, where somehow the rest of the country still manages to get away with it, right? I don't know why you guys can make that stuff happen and the rest of the country can't, but I think the EPA's got the same idea, you know? Huh? Yep. I got a feeling that's where to go with these guys too. 3% cap is kind of what the rule states. I think they've been looking at these. Yep, current cap's in the range of 0.2%. So they've been looking at these numbers and seeing if you've been taking advantage of these DOR numbers. And they've been putting they've been lowering some people's caps so that you can't just put everything on DOR and get away with it. They're wanting everything monitored. Negotiate for the highest cap you can for the DOR stuff. Oh, of course it's going to be very hard to do. Try to get components that are committed to be replaced or repacked excluded from the cap. So if you have one that you need to put on DOR and you're going to replace that next turn around, try and get that taken off of your DOR cap, I guess is what that's saying. Some facilities prefer a clamp rather than drill and tap. Again, in California, they use a mixture of all of it. Drill and tap doesn't work. I'll bring in a clamp overnight. So, started including a requirement for direct maintenance into draft CD languages. So, quasi-directed maintenance, which requires repair verification and monitoring within 24 hours of the physical repair attempt. That one's not super hard to comply with, but it's never any fun. I know recently I was doing, the Colorado Regulation 7 rule just came out, so I've been working on that quite a bit, and one of the things in there is they're allowed to do a repair attempt within the 15 days, and then it restarts the clock to go out and do the re-monitor. So you don't have to do it within 5 days of finding a leak. You have to do it within 5 days of making your repair attempt. So it's kind of quirky language in that rule, but this one's saying you got to get out there right after it. Newer draft language calls for concurrent repair attempt and monitoring. So at the same time, be out there while the guy makes the repair. Oh man, I thought that was 20 slides already. EPA has started to include a pass-fail. 60, they said, oh, 20 pages. Oh. It's all the same, right? No, it's all right. Huh? That's okay. I'm not too worried about it. Corrective action is required for audit leak rates greater than 3 times the leak rate that the site reports for the previous 4 quarters. So if the site reports a leak rate of 0.2 and an auditor comes in, audits the unit, and they find a leak rate of 0.7, you got to have a corrective action plan put into place. Huh?
This part is actually based on, he's correct, but it's based on the past 4 quarters. So an audit will look at an 8-quarter window, so 2 years worth of data. And this part of the consent decree that he's talking about, that would cause a finding to be put in place in the last 4 quarters. So on those, you have to analyze it. We have an 8-quarter leak average.
Are they, let's see here, does it say it in there? Consider language for, is there anything in there about like 5% absolute difference between the site leak rate percent and the audit leak rate percent? Yeah, I know that like this places with leak rates of, you know, down there in 0 area, and you come in as an auditor and you find 1 leak, it's just, you know, you're already guaranteed to be 3 times as high. So some of those get exempt. So look for that if you can.
Yeah, there is a certain criteria that if you find 1 leak compared to a second of 0%, they throw that out as part of it. They say that was okay. We can have corrective action based on that.
But even if you did fix the one, I mean, so what all is entailed in this corrective action?
When you get a finding like this, you basically have to submit what you're going to do to fix it. So this is dealing with basically all of your monitoring history.
Right, so this could bring in like more Method 21 training, stuff like that.
From 0 to 1 leak.
Well,
Not
so
much
that's
you
why
gotta
they
do.
throw it out. They say that, you know, because the potential to find 1 leak first, the 0 leaks, that's a big, if you have a 0 reported leak rate for 8 quarters and you find 1, that's not really fair to you guys, because you have been finding leaks or something along those lines to prove that it's
Is it pretty explicit what needs to be in this corrective action plan?
It's whatever you want to do.
after your very first one, you then have to submit it in with your next semi-annual, because you have to show that you're doing your audits, which are required by the consent decree, and then from there, you basically are showing EPA what you've done to hold yourself accountable. So if this did come into play, then you have to show, here's what I'm putting into place, and here's all the information of what I did to fix it. So it's not something.
Probably not. So that's at that 3-time level. A lot, you're not going to see 3 times a lot. Is there other exemptions in there, like if a unit just came online and stuff like that? I know, you know, that'd be something you'd want to look into then if you're in the negotiation process, I guess. You know, if audit comes in right after a whole bunch of stuff was added or some kind of upset condition just happened.
Most auditors will not.
Right.
A unit that's been upset until you guys have had enough time. Go back in and, excuse me, find the leaks yourself, because it's not a fair assessment when you have that going on, because you have new thermal cycle and everything's coming up with heating, cooling down. And what that is, it can really throw off the repair. So every auditor I know would avoid those units at all.
So go on to the next one here. What CDELP terms are not? Because generally all of the terms in CDELP are negotiable, but the EPA is much less likely to budge on some of the requirements like preventative maintenance, DOR caps, leak definitions, increased monitoring frequencies, and most of the boilerplates, I guess, and a facility-wide program plan, training, audits, and personnel. Negotiation process can yield favorable results if a healthy interaction is maintained with the EPA and if counter-arguments are developed based on a technical merit. Just don't make them mad, basically. Right? It's kind of hard to do, and they come in unannounced, I'm sure, and like out there where you're at, do they got the blue sky audits for you? Yeah, sure, those are fun.
Yeah, but they've kind of gone into a political way of like, you know, like a lot of facilities will tell the operators or maintenance people to like, let me get the proper person that can, you know, answer your questions. So they can't really use all the other questioning to the you know, against whatever the findings they find. So then they'll bring in like some kind of like EH&S department that can answer the questions while they're in the facility.
Gotcha.
Before they walk in, it's just like, hi, I'm here, kind of thing. Now it's like the safety aspect of the facility, so they have to comply with that now. So they have to wait till, you know, like some experts from whatever department, environmental or
That's a good thing then, because it used to just be they showed up and what they wanted they got, right?
Oh, they still show up. You just have to get safety.
I gotcha. There you go. That's the key, huh? It's a 20-minute window. I learned these EPA hot button issues. GGGA and VVA applicability stuff in there. Know and understand ramifications of agreeing to various CDELP terms. Don't agree to something that is going to bite you later down the road. Written facility-wide LDAR plan. Most people have these. You do if you have a CD. But some training, some audits, pump leak definition, valve leak definition, repairs, monitoring frequency, data loggers, low E technology, data QA, QC personnel, post turnarounds, calibration, drift assessment, DOR, and record keeping. Facility-wide plan, all CDs include this requirement. There you go, you were right. Covered, huh? Well, yeah. Get on that. Coverage of coverage of federal only versus federal and state LDAR. Deadline by the date versus the day of CD lodging. Use of pumps and valves versus equipment. It's just things to look for in your plan and put in there. One of the things you see usually in a written plan that may be something to look for is your unsafe to monitoring reasons and all that stuff. Each component has to have a reason for being unsafe. You can't have a blanketed reason for a set of stuff, so each one has to be itemed out and the reason why it's unsafe and when you will go out and try and monitor it. Right. Plan approaches, two basic approaches. Develop a facility-wide plan. It's the easier approach. Or adopting your existing LDAR program documentation to meet the facility-wide plan requirements. Generally, it takes more work to do that. Start over, start writing. Create a new facility-wide LDAR plan on a major heading for each CD requirement. So you'll have all the requirements listed out there, gone through all that stuff. Minimize text so that you show compliance, but you don't show a whole bunch of other stuff in there, you know.
Alrighty, y'all. So what we're gonna do is kind of just finish going over this stuff, and then if we do, we'll have some extra time. So during that time, we'd love it if you guys want to start coming up with your own questions, and we can kind of make it a more open group, QA/QC, or QA/QC. Well, I've talked too much LDAR today. Make it a more open discussion and have a question and answer time, and you know, we can talk between sites and see what, well, this is how we handled this issue, and this is how we handled this, and really work together and, you know, hopefully bring something beneficial too for y'all. So, sorry. So with this, we've been talking about written plans. And I know earlier today I mentioned written plans, and this is basically the Bible to your LDAR program. And if you want to invest a lot of time, this is a great place to truly invest your time. Because with this, what you're going to be doing, and with the written plan is what you'll be doing is basically giving this to anybody that comes along in your program. So it's something that you can pass off to management. It's something that you can pass off to your monitoring technician team or your contractors, or if somebody comes in to audit you, you're able to pass this off so that they know how you function. It's kind of where you, even in the gray areas where we talked earlier this morning about 180 days and 30 days, it's where you can put that information in that this is how we are taking a stance. This is what we've chosen as a site. This is what our buy-off is. So then you have that support documentation already. So for here, keep files for the life of the CG. So with this, these consent decrees were put into place. EPA came out and said that they should last about 8 years. Well, I've never seen anybody negotiate out of a consent decree, except for like Hovenza, and Hovenza shut down, and now they're just a terminal. So the only way that you truly can get out of one of these, at least that anybody's ever seen, is by shutting down. Folks have been triggered into a new consent decree. So as time has gone on, like David said earlier, they've hit most of the refinery industry. There's a couple outliers still that are coming onto play, but they're moving into the chemical industry as well. And with this, they've learned a lot, and they've learned a lot of best management practices, and that's what these consent decrees truly are, is folks that went up and beyond at their own site and electively chose to do something. So like we've talked low E components and leaking points. Chevron actually invested a whole bunch of time into this. His name's David Rees, and they actually developed their own type of low E packing set. And by spending this time, they were able to dramatically reduce emissions in about 3 years by just trying out new technology and looking into the engineering side of things and really investing in that. And so some of that got brought into consent decrees because people electively chose to do it. And that's what these are. So, plan with existing procedures. So when you're making these written plans, you also have SOPs and you have maintenance procedures and all this stuff already incorporated at your site that your maintenance guys do, or what you guys did before you got into a consent decree. Like you probably have an SOP for how to put ink into a printer. You know, everybody always has some type of document going, and it's basically to help you. So with this, don't try to add in and make up your own procedures. If you already have them developed and you already have them that's been a part of your site and you know that works, because we all vamp them to work for our site, don't waste your time trying to put something else in there. Just grab it and put it in of the procedures you already have, and just helps boost your written plan. Add sections where the CD requires something not covered at all. So with this, in the consent decrees, you're going to have like minimization attempts. So some folks, if it goes over 100 ppm, you have to make an initial attempt at repair. It didn't trigger a leak. It didn't trigger a federal leak. It didn't trigger a consent decree leak. but it triggered a minimization attempt. And so you actually have to have logs, and that's where databases come into play and whatnot, that a technician actually torqued on the valve, or that you did something to help catch this. So what their belief is if you take a proactive approach by finding something that's either 100 ppm or a little bit higher but hadn't triggered a leak yet, by you torquing it and making an approach to fix it, you're being proactive, so its potential to leak actually is less. And I don't have the data to prove or disprove that. It just depends. But like we said earlier, if you are going to be doing those, make sure once they torque them that you kind of step back and give it a second to clean out the space around it, because you're going to be pushing everything out and you could get even higher reading. Usually it's better to kind of just wait a little bit and come back and do it. Revised sections impacted by the CD to show how overall compliance with state and federal LDAR rules and the CD is accomplished. So what we're getting at here, and a lot of folks, like we keep talking about databases, in your database you're going to have many rule sets. And so if you're, let's say I like California because they got so much stuff going on. They just have so many rules inside rules. But so with your database, let's say you have valve 1. Well, in your database, you're going to be clicking many applicable regulations. So you're going to have your federal regulations. So you got your max CC. So there's your 10,000 ppm level. Well, now you might be in an NSPS GGGA unit. So now you have to put that rule set onto that component. And now its leak definition is 500. Then if you're in South Coast, they have their own 1173, which has a 200 ppm leak definition. So now you have to apply a whole nother rule to this one component. So just in that one valve, you could have 3 different rules. So what are you doing here? You're showing how you're going to comply. So a lot of folks, what they do is when they take this, they put it together, they look in their database, and they're able to see what rule sets they have and what is applicable. And by that, then they can just put that into their plan of here's how we're complying. So with South Coast Rule 1173, most folks just say this is my most stringent and this is what I'm going to comply with because the leak definition is lower and my repair time frame is more tight and et cetera and et cetera. But when you do that, you also want to make sure that you don't miss some nuances. So for example, with 1173, they have pumps have to be repaired by day 6. So they don't get 15 days, they get 6 days to do it. Well, from that sounds very more stringent, correct? Compared to 5 and 15 day? Are you all in agreement with that? So with that though, they say 6 days for final repair, but your federal requirements say that you have to make an attempt within day 5. So now you have a stringent final repair deadline, but now you've missed your first attempt requirement for the federal piece. So when you start looking and playing with this, and especially in this area, it's easier to set up like a little table or an Excel table and go, okay, here's what we want to comply with, and you put it side by side and go, okay, 4 pumps. Here is what the federal government says. Here's what my state says. So I have to comply with this. And that's what this section helps you do, is being able to label it out and show and help you guys make sure that you capture anything. Because the last thing you want to do is take a ding for something that, well, I have to repair it in 6 days. It has to be repaired. Well, now I'm taking a ding because I missed my 5-day from the federal side, and you have to self-report that as a deviation. So, and that's never fun. I don't know if you guys have dealt with that before, but reporting things of where, I'm sorry, please forgive me, I messed up, is usually not a fun thing to do. So consider adding pointers to show how each CD requirement is covered if they are spread out. So what we're getting at here is after you do all this, you're going to have, with your consent decrees, we've talked about minimization attempts. You're going to have different repair schedules. You're going to have different leak thresholds. You're going to have probably different components come in, because most of the time when you trigger into a consent decree, what EPA is doing is they're forcing you to go into the newest, most stringent rules that's out there. Most of the refineries went from being a MACT to triggering NSPS VV or GGG. They're both if you read those rules, they're both pretty interactive together. They back reference GGG back references all of VV, basically, inside of it. And then they added in GGGA is where they're pushing some new folks now with newer consent decrees that you have to now be applicable to this, which would be a more stringent rule. So as they're doing these, you're going to be adding points of making sure that with your consent decree, you have everything covered that potentially needs to take place. And so with these written plans, that's what you're doing, and you're covering that requirement. So, leak rate goal, and this is another piece that's in the consent decrees. Requirement is to identify a facility-wide leak rate goal that is achieved on a process-by-process basis. So what happened was when these consent decrees came out, when you went to the negotiating table, they said, I want you to give me a goal. So let's say you had your facility as a whole was 10%. Well, what they wanted you to do is set up a new one. Most folks chose 2% as their total overall leak rate. Now, when you start breaking it down, you might have one unit that's 1% and then all the rest of yours are super newer and have newer equipment, so they're at 0.2 or 0.01 leak percentages. Most people didn't think that was achievable, going from 10% down to 2%. Well, now, with the data that we're seeing, and EPA sees it too, because you guys are all reporting it out there to them, they're actually seeing that you can even go lower now because engineering's got better. Our ability to fix equipment has got better. And so now you're starting to ratchet it down again. And so everybody basically in the petroleum side took a 2%, and we're seeing right around 1 now for most facilities. So a 1% leak rate across the board. But like I said, they want it by process basis. And so you have an overall, and then in your written plan, you would put this unit X does this. And you want to show the old data, not this is where I want to go. So you want to have a 2%. And this is why I say less is more sometimes. Less is good at point, is because what you want to do is say, okay, here I have a unit that's leaking at, let's say, 2.8% at the time that you're coming into these negotiations. Well, you don't want to go in there and say, well, this process unit is now going to go to 0.2%. You don't want to lock yourself in. You want to say, here it was our data, here's what was taking place, and then you want to move forward and say, overall, I'm going to shoot for 2%. Because maybe something happens to that unit, it catches, and it sounds terrible, I'm sorry, but maybe it catches fire or something like that goes on. Well, now, of course, yes, you have lower emissions because it's not running, but now you have to go in and replace a whole bunch of valves and things like that. All of a sudden, maybe you reduce the emissions in that unit heavily, but one of your other ones that was supposed to go down because you said you were going to go to 0.1, and now this one you had to do all sorry, my tongue is not cooperating. Maybe with the other one you had to do all the information and you put all of your procurement money and capital project money into rebuilding that unit. Well, the other one you said was going to go lower, and now you're locked in, and it's a bad thing. So that's when less is more. Does that make sense? Sorry, it kind of came out a little jumbled. My brain was jumbling it all together. So some have worked from the bottom up, look at historical leak rates by process units, pick an achievable goal leak rate for each process, do a weighted average to determine the facility-wide leak rate goal, and an opportunity to develop some meaningful metrics and goals for continuous improvement. So with this, you're digging through all this data already. You're having to get it together. You're having to get it put together so that you have proof of what you're doing, proof of compliance. Well, if you're already pulling it together, why don't we analyze this data and figure out things that we can put into place to make it better? And so when we're saying at the bottom here, develop meaningful metrics and goals for continuous improvement, look at it, see, okay, hey, you know what, in this unit, I've seen leak rates start going down. What have we been doing different? oh, well, we have a different maintenance manager that's over there. And you go in and you go, what are you doing? Because my guy that's in charge on this direction, we're not seeing these types of results. Well, as you start to pull all this together, you can see that kind of trend or trends and start analyzing it. So then, hey, maybe I just need to have Joe talk to Bob of, here's what we're doing to help better. And then by that way, you're helping everybody get better, and you're helping reduce your emissions, and you're helping, you know, basically stay in compliance and not get yelled at. But so when you have all this data in play, you might as well use it for somewhat of a benefit to y'all. Oh, that's a double clicker. So training approaches. In these consent decrees, did I? Sorry, I thought I had. Okay, so for training, that makes more sense. All CDs include this requirement with some minor variations. So all of the consent decrees like BP, you can actually just Google. You can type it in and type in consent decree for Murphy Oil. And it's a legal document. You can pull it up and you can read it. It's about, some of them are 200 or 300 pages long. They're very dry. They're very, very dry because they encompass also not just LDAR, but you're going to have flares and B1 and like certain process units, adding in a tail gas treatment unit, all these different requirements within here. But under the LDAR section, and it's the only part in a consent decree that you'll have a part that's for just leak detection and repair, but nowhere else in the consent decree does it call out required training. Okay, only in the LDAR section. B1 does, but it's one time. There's not an annual requirement. Maybe, does your BP one require it? I'm sorry. I haven't. Yes, so round 2 does, yes. Most of them, and excuse me, I was incorrect. His new consent decree at their BP Whiting facility up in Indiana, right?
Yeah, it's near Chicago.
Yeah, that's where I fly in every time I've been there. So, but they actually have a requirement in their B1 section to do annual training too. But before that, it was only in the LDAR section. And within here, what it says when you look here, it says compliance date or within a year of lodging. So basically within 1 year, you had to have everybody trained in your facility on LDAR. Now what does that mean? Does your maintenance man need to understand the regulations and every bit and piece about everything? No. So what a lot of folks did is they made custom trainings. So you have your maintenance staff and your operations staff training. They need to know what OELs are, why they're important to look at. They need to understand the 5 and 15-day repair. In some of the consent decrees, and you'll find this when you read them, some of them have a 30-day repair requirement if it didn't trigger a federal leak. My advice to you is don't tell maintenance or your operations that. Just tell them they have 5 and 15 days, because then they're going to be questioning, well, is this a 15-day or is this a 30-dayer? And then you start running into a whole bunch of issues of missed repair attempts because they might think that this is a 30-day when it actually triggered something into the 15-day requirement. So those are the items that I would add into a training. And so non-LDAR folks or LDAR personnel that don't do it as their main level have to have training every 3 years. Every consent decree is a little different. So some you might read might have it as every 2 years, some might have it as every 1. It's all dependent. Most folks, to satisfy that, we all have to take like annual trainings according to OSHA. You guys all have the little CBTs where you click the button and we all enjoy doing them. They take hours to do. That's where a lot of folks have done it. They've put that in there to just, okay, here's another module you need to complete. You have an electronic stamp that it was completed and away you go. Now what you guys put in there is kind of up to you and based on your site and your wants and needs. But for the other part, for main LDAR personnel, so like your LDAR coordinators and anybody that's main role is LDAR, including your technicians and the guys at the site, they have to have training annually. So what does that mean? You can give your LDAR technician training and satisfy the rule and put it together and mark it off and sign the boxes and away you go. Well, who does it for you? So like sitting through this course, will give you that annual training. You get a certificate of completion at the end, once you guys sit through 2 days of me and David talking. But what it does is it satisfies your CD requirement on that side. We have other folks that teach them all across the country, and they go to those. It just depends. It's not just for C, but what I'm saying is you have to do it annually. And what's the big kicker? You got to keep all the documentation for it. So if something did happen, you got to have the proof. And that's where, when I go in site to audit somebody, I will ask them, please show me your last 2 years of training records. No, I don't want to see the scores. I just want to see proof that it was done. And so usually they have a nice big spreadsheet that they sign off on that says, I received this training and here's the date, or something like that to show that you've actually received the training. And you have to have trust. So like if I'm auditing and somebody shows me that documentation, I have to trust that they actually did it, not that, oh, shoot, and away you go. So make sure it's something that's believable too. New LDAR personnel, most have the contractor provide basic training. So with this, most everybody does not do LDAR in-house. They have a third-party contractor come and do it because it's a very daunting, time-consuming job. And the role of going out and monitoring a valve every day and monitoring 300 to 500 components every day gets very mundane and not very fun. I mean, I usually just am singing out there when I'm doing it, not a do-do-do-do-do, you know, trying to have fun with it. But with that, you want to make sure, and the contractor does this, they provide the basic training that's needed. And the consent decree requires it, so make sure that that's documented. All provide additional training on facility-specific issues, mostly safety, but on a few operations and types of components. So as you guys have seen throughout today, there's a ton of components out there with a ton of different leak interfaces. Well, we all know already that Method 21 says that you have to monitor anywhere that there's a potential leak interface. So if I was Joe Blow off the street and you pulled me in to be your LDAR technician, I can't just say, hey, go monitor that. Well, he doesn't know. So contractors put together a very detailed training of all these types of components. Yes, once you've monitored a gate valve, you can monitor any gate valve. But when you start getting into the orbit valves and the twin seal valves and the more difficult components, you have to actually kind of refresh their memory all the time, because those types of valves you don't see all the time, every day, in day and out. So those ones you want to make sure are getting captured and getting updated. And then for site-specific issues, mostly safety, you know, so we see where they actually put in some information of, you know, at, let's say, well, I'll just pick on you because you're in the front, at BP Whiting, this is what we require. You need to have your 40-hour HAZWOPER, you got to have your basic plus, and here's our site specifics. If an evacuation happens, here's where we muster. If you're in this section of the plant, here's where we go. And so that's where a lot of this comes in too, because it helps make sure that, A, we all want to go home every night. Well, we want our staff to go home too, to their families. And so it helps that side too. Another piece that a lot of LDAR contractors do is before anybody goes into a plant to do by themselves work, they usually have a shadowing going on. And so by that, what I mean is, you have Joe that came off the street, has no idea what LDAR is, and you put him with one of your good technicians or one of the people that's an up-and-coming star, and you let him go out and watch him do his job. And he shadows him for, you know, some folks even require it for 3 weeks. And then after a week and a half, they switch. Now, your star is now watching Joe do all the monitoring. He carries the pack and helps him and makes sure. So then when you let him out to do things by himself, he's been trained. Because we can all sit here and talk and put up PowerPoints that are very pretty and, you know, put all this together, but without having real field hand knowledge, sometimes it just goes kind of like this. Because maybe, I don't know how many folks actually go in the field every day, but sometimes you're going to be going, well, I need you to go sniff that twin seal. Well, if you've never seen a twin seal, How do you know what, the leaking interfaces are? You have that firsthand knowledge that helps do everything. And so that's where this apprenticeship period is a very good thing. It helps them start to understand what's going on. LDAR personnel refreshers. Many have the contractor provide refresher trainings. Some use CBTs. Some bring in a training contractor annually. And some have refresher training on some LDAR topics every month or every quarter. So as you can see, to meet this requirement, there's many approaches that you can take. I do know another company that what they do is they have a monthly call, and they log that. So every month, they have an hour call with all their LDAR coordinators. They get together about a topic. And with that topic, they all discuss it and talk about LDAR and do that, and that satisfies their training requirements for the year. But instead of having a 2-day or 3-day deep down training, they decided that it would be more beneficial for their guys to always keep it kind of in their heads, or gals, I'm not sorry, that with that, if we do it once a month, we always have this on our brain. We always have certain topics that are coming up, or certain sites have different issues that maybe your sister site over here has already solved. And so by getting on these calls, you can help solve that problem. I hit on this already. This is just talking about CBTs. I'm sorry, I got a little bit ahead. And just what you can include, and more talking OELs. And how much do you think one of those little bitty metal tags cost to hang in the field? One of those pretty nice tags that say environmental LDAR program, do not remove. Like y'all have seen those, right? Or yeah, they're $3 or $4. The really nice expensive ones. And then you can go down to a yeah. So yeah, but I mean, so if you add in a tag, then you add in the technician's time that you've already paid for him to go do this. And then you have to upload it into the database. And you start thinking about truly how much that one tag costs you. You don't want those to fall off and just walk away and disappear. So being able to sit and talk with your operators and your maintenance guys who are out there ripping stuff off, and the painting crews, that's always the best one, when the painting crews come through and just paint over all your tags. Now it's, well, is this valve 1 or is this valve 1? And you're trying to figure it out. And so with that, by being able to put that type of information into why this is important for your non-core LDAR people, so operations, maintenance, hey, if you see a tag fall off or you have to pull one off because you're breaking this line and putting in some new equipment, please get it back to me. By the time you show some real data of, hey, by the time we hang one tag, you're looking at a good couple grand probably by the time it's all said and done, of just cost and all of this put in together. That kind of helps them think a little bit more. And then it may include, oh, it's on there too, gosh. But with that, oh, sorry guys, well, technical difficulties. But with that, like keeping tags in place, or what did we talk about earlier today? We talked heavily on sample stations and putting a lid on a bucket. You would not believe how that just kind of seems to not make sense. I don't know. But with that, what you would want to do is put that in the training. So those places that they're going to impact your program, the places that you don't want to get a deviation or get hit for because those folks are not doing it correctly. When it's super easy to say, hey, put the lid on the bucket. It's in your training. So then when they come back and say, well, you never told me that, you can say, well, I see that you took this test or this CBT and it says that you completed it. Well, in there it talks about putting the lid on the bucket and, hey, put the bolt plug back in when you take it out of the line. Super simple things. So that's a good place for this. So unique aspects that we've seen or training approaches, some have drawings or physical examples of components. So like what we showed you guys earlier today where you saw all the arrows and then like you had a green arrow that came in and said this is a potential OEL. So, and you'll hear us talk about a POEL, which is a potential. It's not an open-ended line yet, but you have the potential to do it if this isn't in place. So that's a great place to show them of, hey, this is a potential open-ended line. You guys really need to make sure, because the going fine's like 10 grand. So here, if you put this in, we don't get dinged 10 grand. Things like that. Others, what they've done is they send y'all, like you are here at this training. Well, yeah, it's great to come up and listen to me talk. I know my voice sounds beautiful to you all on a Monday morning, or afternoon, I guess, at this point. But with that, what you want to do is be able to network with other folks. So don't be afraid to go outside of your box, because if you do have an issue or you do have something, I can guarantee if you go talk to, Mike over there and somebody else, they probably have already taken it on, and they can give you ideas how to better your program, how to better put things into place. So that's a great way to do it. ISA is another one, and it's strictly an LDAR conference. Anybody that's there is strictly there for LDAR. So they don't have air permitting and wastewater and whatever other trainings are going on currently here. It is strictly LDAR, and it's usually, I believe, a day of training and then 2 days of presentations just on LDAR topics. There's a couple other good ones. There's one in Dusseldorf, Germany that you guys can go to if you ever want to go to Germany. It takes place in December. It's a really fun time. Yes, sir? Somebody say something? Oh, sorry. Okay. LDAR University courses. So what you're sitting through now is HSEU. That's our affiliate, and we provide courses all over the country. And then the 4C conference. Other facilities had a process training facility with working modules of distillation columns, pumps, and etc. So we've seen them get down to, as we were talking earlier, about being able to know what's in the pipe. You need to know what's in the pipe to be able to understand if it's going to be a slow response time or if it's going to be almost instantaneous. So with one of the trainings that we saw, they actually broke it down where before they could even go in the field, they would basically sit through operations training, and they would be with them for a couple weeks. I'm not saying you need to get to that level, but they would sit down and learn how each process unit worked and what it did and why you have, a cat cracker, why you have a coker, why you might have this batch process running depending on where you're at. Let's see. So we've talked quite a lot about this too. So audits, and in every consent decree they have an audit requirement. And what it basically says is from the date of entry, and depending on if you were one of the first, most folks don't have it now, but the very first audit was a forgiven audit. So you could go in and find any issue that went on, and it was your forgiven. EPA saw it, said, holy smokes, we got a whole bunch of stuff going on. You guys put a corrective action in plan, but you couldn't get fined. They weren't going to put an enforcement action out on you based on this. Well, as the CDs have gotten more integral and more people have come in, they've taken away that forgiven. And so the way that EPA makes sure that you guys are still complying with it, because they can't be everywhere at once, they require audits. Well, so every 4 years, so it says every 2, every 4 years you have to have a third-party auditor. And then every 4 years you have to have an internal audit. But it's not 4 years spaced out 4 years. It's every 2 years. But once you read through all of the stuff in the consent decree, you have a third party come in, and then within 2 years of the close of that one, you have to have an internal audit, and so forth and so on. And it just keeps going. Now, you can't audit your own facility. So some folks who have a lot of staff actually have their own LDAR auditing team just to do the consent decree requirement for internals. And they pull 3 or 4 people that know LDAR, and they go and help audit one of their sister sites. And that satisfies it for the internals. But then you have third-party audits. So Sage Environmental does them, EMSI does them, ERM does them, and there's probably others. Those are the big names I always hear. And so with that, they go in and audit from a third-party aspect. And each one has different pros and cons, so don't get me wrong. And so they're another one that you can reach out to. But with what has changed now with consent decrees is when it went into the chemical side, they now went to where they require an annual third-party audit. It's no longer we get to do every 2 and every 4 years we have to pay somebody to basically come do it. No, now every year you're going to have an audit done by a third-party contractor. And it's whoever of your choosing and whatnot and whatever data you hope to get out of it. Usually having a better team come in to audit you is a great way to go, because you'd rather find the issues and get them fixed, because when you report an audit from a third party, you have less of a chance of getting in trouble because you're self-reporting these issues versus EPA coming in or the California Air Board or somebody coming in, where I know on the South Coast, when they do blue sky, they just have a little ticket machine right there. Before they even leave the site, you know how much you're getting fined. And it just says, please pay this, and away they go. So with that, that's something to think about, because you would rather find the issues yourself, report them, and hopefully you can get out of things if it ever did come to it, than have an agency folk come in and do it. Yes, sir.
So what, I was unaware that chemical facilities are getting this every year.
They also have a leak definition of 250.
So what are they holding over? I mean, what is EPA? I mean, you do this as a negotiation. You do this because you're getting relieved from some other kind of enforcement action. What are the things that they're finding that are making people agree to annual audits? You got to remember, this is an agreement.
Your guess is as good as mine.
Okay.
Usually it's probably an easier bargaining chip of, I don't want to go build this whole new unit to do something or replace and add in flares, or I mean, I don't know.
Yeah. So
So if I absorb, let's say, a $50,000 a year cost to have somebody come in versus investing $2 billion in something
well,
else.
it would typically, but not always, have something to do with the current LDAR program, some inadequacies in the current
Yeah.
LDAR program.
And that's,
Suggest that. Not that you couldn't, not that it could be some other flare issue in the agreeing.
I've seen folks where I've been helping as part of a negotiation with EPA, helping negotiate their consent decrees, and with one of them, it was basically, I would rather have all of this if you step away from this issue over here. Make me have low E, make me do all this, because that's a hell of a lot cheaper than what I was going to have to do on this end. And so we've helped clients put together cost analysis to basically see, okay, here's the worst case scenario of what we've seen presented. Here's what your annual cost would be of keeping that in play. Versus then they can look at what it would cost them to do the other items that are on the table to come off. Because like you said, it is a negotiation. But once you sign that dotted line, you're locked in until the luckiness of somehow proving that you got out of it, which nobody's done that yet. We talked about this. I'm sorry, like I told you all earlier, I kind of like to stay away from the slides. But the key issue is get someone you have confidence in that will find 100% of the problems in that first audit if you have that relief. That is when I would recommend pay for the biggest dollar of your buck and bring in the most senior people that know everything about everything and find those issues. Because if you get the freebie, you should take full advantage of it and walk away from there being happy. Then if you don't want to have that later on, you know, which you shouldn't have to worry about because you've already found all your problems, then what you can do is, you know, go to somebody else or do something else. But it's kind of that information that always is nice to have somebody else. It might not make sense, but that's when buying the Ferrari for that one time is a good thing versus running the Pinto, if that makes sense. I'm really bad with analogies, so. So internal audits, what a lot of folks do is they want to focus on cost. And so with internals, like I said earlier, they've put together task teams, because if I'm already paying somebody's salary, all I have to do is pay for a flight for them to go somewhere to help audit. It's a lot cheaper than trying to do third parties all the time. So it's just something to think about. Or other folks, because you don't have to do it, nowhere in the consent decree does it say that your internal audit has to be with your own staff or a sister company staff. So you can, during your internals, you can also hire a third-party auditing team. So if you really like, let's say, Jake's, and Jake's does a great job for you, well, bring them back every 2 years then, or every year if you're in the chemical industry, whatever it might be. Just as long as you're showing that you're doing the audits, that's what has to be done. Another company that we work with, they like to take this approach. So they'll bring like myself in to lead their audits, but I'm working with their staff to do it. So we still do an LDAR audit, but I lead it. I help them get the data together. We help dig as a team to do it, but then they cover the other cost of where I don't have my full-blown team that would cost more money to do it. They have their team who also learns from it. They're from other sites, so they can also pick up on items that we're seeing going on and help take it back to their site to get it fixed if that is an issue. Use special capabilities of the contractor. So like with us, when we do audits, we have a little bit over, I think last time I looked, 390 consent decree audits performed within the company I work for. And that's one of the best data sets out there because we've been able to benchmark. And what we've done, and we keep it all anonymous, we'll say like out of the state. And we've shown from when they first came around in the early 2000s till now, you can see this a great leap of people doing things better. OEL control's gotten better. Overlooked components that should be in your LDAR program have gotten better. You know, we used to be able to go out and find at a minimum maybe 100 easy that should have been in your LDAR program receiving quarterly monitoring or something along those lines, where now maybe we find 5. You know, an audit team is never going to walk away with not finding anything. So I hope you guys understand that. But as it's gotten more and we've gotten more robust and people know, you know, have taken a lot more ownership in these types of programs, the findings have also started to go away. Let's see, internal valve leak definition. So, like we talked about a little bit earlier, with these consent decrees, what they've done is they have dropped your leak definitions down. And so, like we were saying, when you were a MACT applicability, and I keep talking refineries because that's the easiest one that's out here with consent decree, they had a 10,000 ppm leak definition. Well, then they triggered into NSPS, which has a 10,000 ppm leak definition for valves. Well, then they had to sign a consent decree. Well, the consent decree said, hey, great job. You're going from 10,000 to 500. That's a drastic change. So many folks, before they even knew they were getting consent decrees, started to step down. They'd slowly start stepping it down so you didn't all of a sudden just take on this massive change that would go onto your facility. So if you're in negotiations right now or are coming into a consent decree, it's something to be very considering and understanding about it. You don't want to overload your maintenance people and your operations and whatnot, because when you take a huge step from 10,000 to 500, just imagine all the leaks that would fall into that range compared to what you used to report. They did the same thing for pumps. Pumps went from 10,000 to 2,000. And then when you start looking at the chemical industry, they said, okay, well, if the refineries can do it, the chemical facilities can do it even better. So what is their one main goal? Their one main goal is to get to 0 emissions. We all know that that's never going to be possible, but you can slowly see that with implementing these types of things, we've helped reduce emissions. And so with that, they took valves from 10,000 down to 250. And in some of them, if they even leak once, they have to be completely replaced. And so that's a big step. Others, and with them, they also went from the pump leak definition down to 200. And if you guys are ever bored, which I always get bored and start looking at fun data because I have it, just start looking at how many leaks you would have if this was your leak definition by looking at previous data readings that you have, and you would be amazed to see how many leaks this actually is going to bring into your site. So if you're just starting to get into this, or you know that you're going to get a second round CD or something along those lines, start looking at the historical data that you have to better help yourself in the end on these. Yes, ma'am.
So you're suggesting decreasing the rate as you're negotiating so that the change can be manageable.
Yes.
But then when you go to do semi-annual reporting, like
You
how do
still only
differentiate,
you
like,
still
all
only
these
run.
things that are not real 10,000
Yeah.
feet?
So what you do, and that's a very good question. What happens is, so you can go into your database and tell it to pull basically whatever you want. So when you're slowly ratcheting down, that's great. You're going to have that data. But when you go to submit your semi-annual, if your leak definition is still 10,000, you only get the report for your 10,000 leakers. So you're still going to find those, but they're going to get down low. So maybe instead, you know, if you look at all of your data where you have a 500 ppm leak definition, let's say, and let's say in this one unit you reported 60 leaks, okay, for 500. Well then, if I rerun it, because I'm just ratcheting down, I know this is coming, so I'm just trying to figure out where I'm at and slowly work into this, then you run the report for 10,000, and well, you had 60 that way, but when you ran it with 10,000, you only had six that went over. So all you have to do is report those 6 leaks, because that's all you're applicable to at the time. Does that answer your question, ma'am? Okay. Many facilities wait until near the compliance date to make the change in one step. We have seen that, and we've seen facilities get completely overwhelmed. And that's when they call in the contractors to come help, and everybody's jumping on the ground to try to get going because they've just waited too long. That would not be my advice. My advice is, if you know this is coming, maybe you don't know exactly what's going to be at the end of the tunnel because you haven't signed the agreement or you haven't been presented with everything. Do some searches of the most recent consent decrees for your type of facility and see just kind of what's out there. And see what would be something that you could slowly start adding into yours, knowing that, okay, this is coming, but slowly adding this in and taking care of it that way. We talked about this one, and that's the one I just got. And then other facilities reduce the leak definition on certain units at different times. Tell all are 500 ppm by compliance. So instead of telling your technicians, okay, from now on our leak definition is 500, and so they do it in all their monitoring routes. No, what some folks do is they select, here's unit A and B, we're going to go to 500 ppm on that unit right now. And they fix that unit, they get that unit up and going. Then once they're good there, then they move to another couple units. So just depending on how your staff can handle it and what it is, you know, if you have a huge maintenance and operations staff, you can probably handle more of these leaks coming in. But if you're a smaller site where maybe you only have 10 or 15 people, they can't handle all the leaks plus do all their other duties that need to be done. So you need to figure out what's manageable for your site. May wish to put limits on leaks found that stay within the maintenance capacity. So what we're saying here is maybe if you take this step change and you're just electively doing it, well, all of a sudden you have 10,000 leaks. And I'm just throwing out a huge number. So you have 10,000 leaks. Well, we know that maintenance can't keep up with that. There's no way. So what would you do? Instead, why don't you put a cap on it? Say, hey, once we find 100 of them, then we're going to stop. Let you guys fix it, and we'll come back next month, and then we'll ratchet it down on the rest of them, or whatever it might be. So the key things that I keep saying is do what works for your site. At the end of the day, you know what tough stuff's going to be coming for it. But with these leak definitions, do what's best for you guys. Don't wait till the end to do it all at once. That's all I'm going to stress. The rest, do what's best for you. Pump monitoring. So with this, they lowered the leak definition, and they took in and added in that if it's greater, if it's greater CD, if a CD leak but less than a federal leak, you get 30 days. So we talked about the 5, 15, 30 earlier. The same thing would apply for a pump. Don't do that. Look at your federal regs or maybe your state regs or in the South Coast. Find the most stringent piece, like I was saying earlier, in your written plan. And with that, then you put it in. Don't try to overload with items of this is a 5-day leaker, this is a 15-day, and this is a 30-day on any component. Just try to make it the most stringent for everything within reason. So you don't need to tell operations and maintenance that, but it maybe your pump, you don't have a backup pump and it's leaking and you're going to bring down the process unit or something like that, or hey, I got to order this part and then I can switch over to my pump B, but I can't do that right now because pump B's out and A's running. So if that's the case, then maybe you do have 30 days because it didn't trigger a federal leak definition. So you don't need to have everybody worrying about it. You know, the LDAR people can know, okay, this is really a 30-day leaker. But I'm still going to keep pushing maintenance and operations to get this done in the time frame of the 15 days. But you wouldn't have to report that if it was an issue. Does that make sense? Okay. Very similar to leaks. And with this, like we said, usually try to phase this in. If you guys don't pick up on anything, phasing in is key with consent decrees. If you know it's coming, it's pretty easy to start doing bits and pieces versus trying to implement everything at once. Let's see, valve initial attempt. I know that we've already talked about this, but with it, depending on where you're at, so in the chemical industry, they went to, if it's above 50 ppm, you have to do an initial attempt. In the refineries, some folks have 100, other folks have 200, excuse me. Time varies from immediate to 5 days. So some of the consent decrees have an immediate requirement, some have a 24-hour, some have a 48-hour, and others have a 5-day requirement. So it's basically what's on your guys's. Trends appear to be about 100 or 200, but the one thing to note is this probably will be going away in some of the newer ones because now EPA really likes low emission upgrades. So basically, if you can't fix it, you get to put in a new low E component. And so that's where they're starting to push everybody. So you'll start seeing different pieces start to fall away. But their hot button thing is getting everybody complete with low E upgrades. So one thing we're going to have tomorrow for you guys, and it's on topic with this, is we're going to actually have in another group called Flexitalic come in. And they're going to give you guys a presentation in the afternoon about low E, about flanges, about gaskets, and other things that can go in to help with these types of requirements. And like we said earlier too, is it's not about, let me just get a wrench and I'm going to put my whole butt into it and torque that thing as far as I can go. You know, that's what we used to think. Well, now that isn't the case. You want to tighten it within the specifications that's required. So they spend millions and millions of dollars to do all this development and understanding how things work. And okay, when it hits this temperature, you need to go re-torque it to this specification, and you need to, you know, tighten bolt A, or 1, 2, 3, 4, you know, there's a certain order. Because if you don't tighten it in the correct way, you're not going to get it to set right, and then you're still going to have emissions leaking, and it's just a big thing. So if you're going to do this where you have to for low E, you might as well learn how to do it right and be able, you know, to have the best chance of keeping the best product in. You don't want to pay and then a month later you're replacing it again with another expensive valve. You want to make sure that you understand the importance when they do give you these things. You want to understand the importance of when they tell you what engineering terms are needed and what specification. Do it to those specifications, or you neglect all of the other items that they give you in the certificate. Initial attempt approach, most begin at the compliance date and track data. So with this, the initial attempt piece, you're already, if you've been listening, we're doing the step change for leak rate. Now you don't want to add in a whole nother issue of initial attempts. Okay, if it's at 200, now I torque this, but I don't have to report it and this, that, and the other. No, I would get everything else going and then just bring this in. This is a pretty easy one to just capture right as you're coming into compliance, basically. Although remonitoring labor is higher, the increase in leaks can be reduced if you wait a day to remonitor. So I've stressed it many times today, and I think you guys finally are catching on. If you fix something, walk away for a little bit so that everything can get out of what's escaping out of the packing or whatever you might have torqued, and then come back and do it. Because you're going to be more likely not to have that leak again. Let's see, EPA has not accepted any petitions to reconsider. Do not accept simple majority increase in readings. Want to see how the average reading from the whole valve population changes over time that the first attempts are tried. So when you start implementing this, what they believe is we're doing preventative maintenance, preventative leak maintenance. So they've kind of picked up and adapted on kind of what the Europeans are doing. So the Europeans took an original approach to LDAR as we're going to design. We're going to do engineering and design. And in America, we took the different approach of we're going to go beat the valves and we're going to find those leaks and we're going to fix them. Well, now we're starting to see the flop. So the Europeans are starting to absorb, go out and find leaks and fix them, while we're starting to absorb, start looking into engineering and maintenance and buying better equipment. And so that's what these first attempts are designed to do. It's take that first step into preventative maintenance, that first step into preventing a big emission source. All valves include this requirement with some minor variations. So valve monitoring, most CDs specify quarterly monitoring with no skip periods. Some allow sustainable skip periods for some or all facilities. Allow post-turnaround monitoring without counting leak percent and skip period monitoring determination. Doesn't that sound beautiful? That's just a lot of words that came out right there. So with this, there's only one group that I know of, and that's Chevron in Richmond, California, that actually does skip periods. Now, you'd be really worried because, okay, well, I'm on a skip period. My unit just went down. We did a huge turnaround. Now I'm going in to monitor it the first time. Well, what if all of a sudden my leak rate's super high now? Now that leak rate's going to trigger me out of the skip periods, and now I got to go back to monthly, and then I got to work into quarterly again. Then from quarterly, I can work to semi-annual, and semi-annual to annual. It's going to take you forever to get back to that point. So what they've done is in this, they allow you basically to go in and check for leaks, and it's not going to count against you to where you would have to jump out of a skip period if you elect to use it. Now, I get on my soapbox. I think skip periods are the worst idea in the world. They're too hard to track. They're too hard to manage. And if one thing happens where all of a sudden you have a huge leak rate, and let's say you decrease staff because you don't need them based on everything's on an annual basis maybe. All of a sudden you go in and monitor them and you find out that they're all triggering back to monthly. Well, now you got to start all back over, train everybody up again, bring in new people, catch back up, slowly work through all the program again, get it back into the annual. So my advice and my soapbox talk is just stay on quarterly and just be happy. That's what 95%, 98% of the country does, and just stay that way. Valve monitoring approach. Most facilities use straight quarterly monitoring for valves, even when their CD allows skip periods, like I said. Less uncertainty, easier to schedule labor, less non-compliance risks. And so with that, and this is actually a slide I put together, I've already talked about it, but with that, you're managing your level of compliance risk. So like we said earlier, you have to be the one that if something goes bad, you're the one that's going to be the one that's getting talked to. You're the one that's going to have the red face test, correct? So you want to internally manage your own compliance risk for this. So what makes you feel good? If you do want to do skip periods, go right ahead, if that's what makes you feel good. But you need to learn how to manage your own compliance risk. What feels good to you? What makes you comfortable with your program? And if that's doing that, go right ahead. I would recommend against it, but that's just my opinion and preference. Skip periods. are being more considered, or being considered more favorable when paired with low technology upgrades. So it kind of contradicts what I just said, but when you think about it, if I'm putting in better equipment and stuff that's already designed for a 5-year life cycle, never to go over 100 ppm, you have that certificate, and you put all of that in this unit. Well then, why not go to a skip period? Because it's already been tested. It's passed API 622 and 624 requirements, you know, so it's already been put in there, and now I could see you using skip periods. But if you don't have the equipment to do it, I wouldn't do it. This one is talking about, and I can't remember, I was talking with somebody about this, but basically that everything is required to be electronic anymore. There's really no paper allowed. Some CDs allow you to have a few certain pieces of paper, or if like your data loggers are broke and they're on back order or something's going on, they'll allow you to do some paper monitoring. But now what they want is basically the operator who did it, so that they can see, is this Bob that does this every day? So maybe he's Tech 1, or is this Joe and he's Tech 2? And they want stamps, so you can find the Red Bull wing kid that went from ground level to 9 stories up in about 3 seconds. That, you know, that's awesome. I don't know how you grew wings, but I like it. So with that, that's where these data loggers and all this database stuff comes into play. They're now forcing you to do it. Before, there was nothing that in the regulations that said you had to, but this is now forcing you to do that. I've kind of talked on this one. So with this, if you haven't been around LDAR for very long, the leak tracker is a very older data logger. Now most folks are using Bluetooth Archers or something along those lines, which have windows, and or some folks I've actually seen have actually moved to an intrinsically safe like cell phone tablet. So like the iPhone 6s and whatnot, and they have an intrinsically safe case put around them, and that's what they use. So it's kind of whatever, but those are things that are out there. And there's folks that use Bluetooth. There's still folks that connect the old way. I recommend going the Bluetooth route. It makes everything easier, one less cable that's out there to potentially get caught on. And some other folks actually, one of the sites I go to, their entire site is Wi-Fi now. So as they're monitoring, if something's going on, they can actually push all of their data directly into the database from the field. Or if, hey, this unit we just found out is going to shut down, I need you to go check all these leaks, they can actually just beam everything over Wi-Fi. He can upload it on his handheld and just stay going. So you lose less productivity that way. Just a piece out there to think of. Low E we've talked about heavily, and with this, you have to get this. It has to have a certificate that says it passes this, the manufacturer guarantees it, 100 ppm for 5 years. If you don't get that, don't even put it in and say that it's low E, because without that certificate, nobody's going to believe you, because like we said earlier, documentation. Some of the newer chemical CDs have requirements also for connectors. So with the chemical side, a lot of you folks do HON or MON-based regulations, and so you have connector monitoring requirements. And so they've also added in low E connector pieces. So, you know, changing out your gaskets and using a different type, and there's certain companies out there that actually will make that and give the certification. The last piece is, like David was talking earlier, ball valves. Well, I don't know of any ball valves that are out there that are meeting the low E requirements. So they're commercially unavailable. And each one in each CD has a little bit different writing for what you have to prove that it's commercially unavailable. But that's something, if you guys are ever interested in, we've put a lot of data together that kind of shows what vendors are out there that can meet these requirements and which ones are starting to come into the requirements, just to help everybody kind of stay ahead of the game. This is a lot of what we've talked about for the low E, so do you guys want me to go through all this or just kind of skip over this section? Okay, So some folks want to go over it. So what we're going to do is, with all of these starting to take effect, so there is not much history on how sites will comply, but generally we'll include research of available technology. So I just mentioned that. We have amassed a whole bunch of data for this. Document low-E valves and packing found. Work through engineering, operations, etc. Because now you're going to have a different type of component. Might be a different metallurgy. Might be something that comes into play. So now your engine, maybe the flanges are a little bit different than what they were for your old components. So now you got to not only think of purchasing all this, you got to get your procurement people to buy off, and now they can only go purchase all this. Then you got to work with your engineering department, so when they're designing stuff, they're designing it to within the new specifications. And then you got to work with operations to go, okay, all of those non-low-E valves that we still have on store, you can put them on water. You can put them over here on this. It's not regulated, don't care. But when you touch this line that has an LDAR tag, it's got to have this valve. So now they just got to understand a whole nother level of training. And with some of the consent decrees, what they've done is they have said that, and I believe David touched on it, that you will implement so much per year. So you'll implement like 20% this year. And then you step to another 20%. So after year 5, your whole entire facility should be 100% low-E. But if I go for 5 years, well, now the unit I started on first, my certificates are up. So are those components still holding? What's going on with them? Are we finding leaks? Can I get an addition on this? What's going on? So it's going to be that never-ending battle, just from a different side. For low-E packing, they have that, so you don't have to replace the valve. And with that, the best thing I can do is talk to your vendors, and maybe your procurement guys can get you to the right people instantly. And that way, with the packing and stuff like that, you'll already know if they're on your approved list, or if you don't have somebody on your approved list that can give this information out there, then what you're going to have to do is basically go find a new vendor. And getting vendors on approved lists is usually very time consuming. And so you got to get, the confidentiality agreement in play, and then you got to get the NDA and, all this stuff in play, and it just depends on the site. But, if you can work through your already existing vendors, it's only going to help you. Consider valve design changes only when packing upgrades do not apply. So what we're saying here is it's a heck of a lot easier to replace a packing set, replace your packing gland, than buying a whole new valve. So if you can fix it with just packing, I would recommend doing that, where packing's like $5, where buying a new valve's like, depending on what you're doing, you can $500 to $5,000 to $50,000, it just depends. So if you can fix it with, $5 worth of packing that meets this requirement, that's a heck of a lot better for you and your company than having to buy a huge, big, specialized valve. QA/QC. So all CDs include this requirement with some variation. And what they do is the requirement that the contractor does QA/QC before turning data over to the facility. Company to do quarterly review, including number of components monitored per technician, time between monitoring events, and abnormal data patterns. And I'm going to touch on all these, so I'm just reading the bullet points for you. Newer CDs have added in daily technician certifications, quarterly observations, verifying calibration records, time repairs, sign off on DOR, and all records, etc. So that's a lot, right? So with this QA/QC, what has happened and what's taken place is now the things that you used to do just because you wanted to make sure your data was true and you trusted yourself, well, now you're required to do it. So we've even seen it get down to the point where we have GPS now on technicians, where you can see where they're monitoring at all times, where their points come in. And you can see if Mike's out there having a smoke, but all of a sudden he monitored 15 valves. But, so you're going to see that swing. We've also seen where people have gotten so down and dirty with things that they pull gate logs. And they will look at when people sign in. And some of the units you actually have to badge in, instead of writing it down, you put your badge in that you're out in their process unit, and then you badge out. Well, they get down to that point, and then they start looking at the timestamps that are on your monitoring route. And so if my first reading, let's say, is at 9 o'clock, but I don't badge into the unit till 10, where's that hour? What's going on here? So that's the level that some people are getting into with QA/QC. A lot of folks look at time between monitoring events. So I've mentioned the guy with wings. How do you climb 9 stories in 3 seconds? It's not possible. So by looking at the time between the events, you can see that from finish the reading on tag 1 and to the start of the reading on tag 2, it took him 3 seconds, but you know that there's 9 stories in between those 2 tags. Well, what's going on? And if you don't look at it at that level, all of a sudden now you could have a technician that's falsifying data, which then brings in a whole nother issue for the site and for y'all, and that's just not a pretty thing to take care of. Others have gone to a very detailed order of DORs. So DORs is a license to leak. And with that, you want to make sure that you're getting the right people to sign off on it. So by doing QA/QC and making sure, okay, does this valve truly need to go on DOR? Can I do this? Let me go talk to engineering. It's another way that people are making sure that you aren't just putting things on DOR or just putting things temporarily out of service because you don't want to do it that month. You're staying away from those troubles. You're putting in that information so that everything gets better. So when you're thinking about this QA/QC, a lot of it looks like we're kind of trying to find out if you're getting lied to, basically. And that's truly what's going on. You want to make sure that the data you're reporting you trust. And so with a lot of things like this is a way that you can help control your own compliance risk. Because compliance is what we have to do, and that's what you guys don't want to go to jail or get in trouble or get an NOV or anything of those lines. So with that, if you have heavy QA/QC, before that data even truly hits somewhere that would ever be able to get reported and get in trouble, that's a good thing. I know a couple sites that, and I really like the approach that they took, and what they did is they said, okay, we all have bad days. We all do dumb things, and things take place, and we might regret them, but all you can do is say you're sorry. But the second your LDAR data hits that computer, I can't call it back. So if you come in and you just tell me not to upload that data, I'm not going to ask a question. We'll just take it on tomorrow. I don't want to know, but at least you're being honest that you didn't do something right. You're not signing off on the data you're giving me. Now, if it happens all the time, then you got a bigger issue. But if it happens once or something and the guy had a bad day, or maybe his wife left him, or they're in a huge fight, or he just had a kid and is really tired and he doesn't want to climb all the way to the top of that 9-story tower. Well, all of a sudden he goes through all that and he spends all day monitoring, but he cheats on, 15 of them, let's say. Well, all he has to do is come in and say, nope, and nobody's going to ask questions. It's a good thing to do. It's a good way to manage your compliance risk. Give them the ability to say, hey, I don't want to do it today. And don't ask questions, but it's a good thing to put into play if you ever think about it. Most databases, so how many folks here use LeakDOS? Okay, how many folks here use Guidewire? How many folks don't use a database? Okay. With that, each one of LeakDOS or Guidewire, if you have IPR, EMS, they have a system called leaders. Then you have EMSI has their own system at some of the sites. I believe it's called LDAR. Don't quote me. But there's many different types of databases out there, but each database has its own built-in QA/QC reports that you can run. Now the funny part is that if you run the report one way and run it the other way, you might get conflicting numbers. Well, that's okay. Just track down why you're getting mixed numbers. Maybe you said pull it from this component class versus looking at just valves. Maybe now you're looking at a specific one on accident or something. But you can run your own, or you can run the canned reports. LeakDOS has a nice thing, and so does Guidewire, where you have a dashboard as you log in, and It tells you how many components are still outstanding for the month, how many leaks you have, how many haven't been repaired. It gives you kind of a quick, early gut check every morning. So it's a good thing to look at on that one. So time between monitoring events, we've talked about this one. This is the one where the technician gets wings. And so with that, what you can do is you can pull all of their monitoring history, and then you can put it into Excel and you can manipulate the data. Excel's the greatest invention ever, I believe. But you can put, here's the end time of this one, here's the start time, and just do a quick subtraction problem and see if it meets your idea. So if somebody's, some folks know different units better, and so you're gonna have a faster time. And that's understandable, but at least you're doing the gut check. Because you wouldn't wanna have a brand new guy go out and he does this entire unit in a day, and you have your most senior guy that's done it 14 different times already. It takes him at least 3 days. So now there's kind of a disconnect. And so, that's a way to look at things. Hey, how did you do it? Well, some folks have the ability to route their own routes. And maybe that new technician was able to come up with a better way than the guy that was doing it before, and he just saved you 2 days. Or maybe something happened or something along those lines. So it's just a good way to be able to do QA, QC, but get a good gut check on what you're getting. We talked about this one. Another thing to do that you can look at on time between monitoring events, like we said, we always have data. So another thing you can do is look at how long are they actually surveying the component. So we showed you guys the LDAR monitoring period originally, or earlier today, and with that, you can go through and say, okay, this is a 12-inch valve. Okay, how long did he truly survey? Oh, he surveyed a 12-inch valve in 3 seconds. What's going on here? Okay, well, if you start seeing those same results, maybe it's time to go talk with that technician. Give them a little bit more training. Maybe they're just maybe they don't understand. Well, you told me that you wanted me to sniff the packing, so I sniffed the packing. But he forgets that he's got all the bonnet and all the stem area. He only sniffs in this area because that's what he thinks. So, I caught that by doing a little QA, QC. I'm getting better results, and away we go. Or maybe it's the other side of the coin, which nobody wants to talk about, and you just walk away from that, and you figure out how you're going to handle that with your contractor or whoever might be doing it. LDAR personnel. All CDs include requirements for LDAR personnel and accountability with minor variations. Some sites have incentive programs to improve leak rates. Some indicate that the LDAR coordinator may be either company or contractor staff. And with low-E technology additions, LDAR personnel is expanding outside of environmental to maintenance, operations, reliability, engineering, etc. So what we're getting at here is we're trying to talk about, earlier you guys saw that everybody has required training. Well, maybe in that little core group that you originally were thinking of, you had operations, you had maintenance. Well, now when you start putting all this into play, just look at how that lists. It went from operations and maintenance, now it's reliability, engineering, procurement. So all of those people have to have training. So as this goes on, make sure you're always looking that you're keeping your LDAR personnel up to date on who's getting the training and what. So accountability, most LDAR staff in the, most train LDAR staff in the expectations. Most review the work of the LDAR staff regularly. Mistakes are tolerated to some extent, but misrepresentation or malfeasance, ooh, that's a really big word. Sorry, y'all. It is cause for immediate discharge. So with that, what you're doing is you're telling everybody, here's what I expect of you. We all go to work every day. We all have a role. This is what we know is expected, and that's why we get paid. Well, if you start to lie or cheat, what happens? You get fired. So you would rather be able to give them the expectations. I'm sorry, my phone's vibrating. You would rather be able to give them the expectations up front, let them know, and know that if you do let me put that data into the computer, I gave you that free pass. I wasn't going to ask questions, but you let that data get into the computer system, you're going to be terminated. Because now I got to go back and redo all of your monitoring. And now I have the potential where in my brain I feel like you've been falsifying records before. Now I'm going to have criminal issues come in probably or something along those lines. So by giving out the expectations, it's a good thing. Incentives. So little has been done in this area. And so, you know, we talk about all this data and all this stuff that keeps us in compliance. Well, we're usually trusting those to very young kids out of high school or, you know, maybe even a little bit older. I'm not saying anything's wrong with it, but if you don't get an incentive, you're always going to be looking for that next better thing, to make more money, to be better. So by being able to make sure that you stay in compliance and that you're happy and you're supporting the data, adding in little incentives is always a nice thing. Bring in lunch every month or something, you know, buy some pizza, or have a shoe bet, you know, where everybody can pitch into the shoe and whoever finds the most leaks for the month wins the little pool that's going on, or anything like that. You know, something that can help incentivize them and make it a more enjoyable piece out there where you're still getting great data and you're still staying in compliance, but you're also making your guys happy. Calibration drift assessments. So what this has done is we were required by the federal regulations to calibrate your TVA. Well, what has happened in here is in the consent decrees they added in a drift check. So now you have to come in and do a drift check on your machine at like lunch. So you now have to do bump checks basically to make sure that your machine's staying within calibration, instead of waiting all day to do your end of day to get out of there. So it helps you kind of capture if anything does go haywire beforehand. Delay of repair. So early consent decrees had extraordinary repair attempts required if it was over 50,000. And if it was over 10,000 and or 3 years. Some of the other CDs that have come on, so we're talking right here is early 2000s. So this is going to be like your BPs, your Exxons, the original big boys that came into consent decrees. So their DOR stuff is 50,000 and or 10,000 ppm for greater than 3 years would be allowed on delay of repair. Well, then this is when kind of like mid-2000s, after they'd got some folks into the consent decrees, and moved into this one. Now, anything above 10,000 has to receive at least 2 drill and tap repair attempts before you can place it on DOR. On top of it. So before it only had to hit this, well now we're trying to do an attempt to repair it and do an extraordinary repair attempt before I'm allowed to put it on DOR. Then, with recent CDs, they require 2 drill and taps for any valve, yes, this is the right number, leaking above 250 ppm. So in the chemical consent decrees, for anything that's above, you got now a 50 ppm window before you have to do drill and tap requirements to be able to put something on delay of repair. So as you can see, everybody's, you know, here's where we originally were, and this was a stretch. Well, now everybody was able to do that, and somebody started doing this, which was a better practice. Well, then EPA absorbed this, and then so on. And that's how it went. So most allow time beyond 15 days to complete the multiple drill and taps for the leaks below the regulatory leak definition. So if it is just a consent decree leak and not a federal leak, most of the times they allow you to go past that 15 days to a 30-day window like we've talked. Non-routine repairs are suggested to include, before you put it on delay of repair, start looking at doing hot taps, line freezes, or anything along those lines to try to just get this component out instead of putting it on DOR. And then also with delay of repair, they require you to have somebody sign off on it. Most folks have moved to where it's the plant manager now before a component's allowed to go on DOR. Record keeping and reporting has gotten even more stringent. And what it's done is it's taken where at the end of your semi-annuals, you have to submit everything that your consent decree requires. So when you read these consent decrees, you can actually scroll down and just type in record keeping and reporting. And it will tell you absolutely every little piece that you have to keep and submit on top of all of your stuff you were previously submitting. And so the list is very long, but it's something where they've added in a lot of stuff. It's how they're keeping track that you're doing this. CD implementation conclusion. A detailed work plan is necessary in order to minimize impacts to the facility staff and meet CD deadlines. There are several approaches for completing CDLP requirements. Best approaches utilize facility-specific management system and enhance existing procedures. To implement path of least resistance. So with all of this stuff that's going on, and I believe this is probably the last slide, am I incorrect for the day? Huh? Oh, goodness, I'm sorry, guys. And it's 5 o'clock. But with this, what I would say is try to help use the items that you already have so that you have a less chance of people pushing back. If you already have things into place and procedures in place, just vamp them to meet what you need because you're going to have a lot less pushback with folks. So it's 5 o'clock, correct? Alrighty, guys. We'll see you tomorrow bright and early. If you guys want, you can leave